You know, I feel like we used to think of software as something entirely invisible, like weightless, right?
Yeah, completely. Just a bunch of ones and zeros floating around in the cloud.
Exactly. Completely disconnected from the physical world.
Right. I mean, the whole appeal was that it felt magical. You write some code, and suddenly it just exists everywhere, instantly, without any, physical friction.
But then you look at what is happening with artificial intelligence today, and that illusion just completely shatters.
Oh, absolutely.
We are realizing that the cloud is, well, it's actually made of steel and silicon and copper. It has a massive physical footprint.
Yeah, it requires land, water, and just an absolutely insatiable appetite for electricity.
Which brings us to today. Welcome to today's deep dive. Today is Monday, July 13th, 2026, and we are working through a massive stack of source material from the Daily Tech Reader for you.
And we've got a lot to cover today. Earnings reports, regulatory filings, some major geopolitical developments.
Yeah, and our mission is to synthesize all of this for you. Because when you stack these stories side by side, a hidden, overarching narrative really emerges. AI is no longer just a neat software tool. It is physically, economically, and systemically rewiring our entire world.
And the scale of that rewiring is, it's unlike anything we've seen in modern industrial history.
So we are going to take you on a journey today, one that starts right in your pocket with the skyrocketing cost of your next phone, moves all the way to AI data centers literally being launched into orbit.
Which is still wild to think about.
I know, right? And then ends with a geopolitical collision over who gets to write the rules for the future of intelligence. So let's start with the most immediate impact you're going to feel, which is right in your wallet.
Because before an AI can actually think, it has to be built physically.
Right, and the sources show the companies building that physical hardware are seeing astronomical numbers. Take TSMC, the company that manufactures most of the world's advanced chips. They just reported a record second quarter revenue of $39.6 billion. That is up 36% year on year.
Yeah, and to understand why that number is so high, you really have to look at what they're physically struggling to do right now. TSMC is urgently adding 2 advanced packaging plants in southern Taiwan.
Just to keep up.
Exactly. They're trying to ease this severe bottleneck in a manufacturing process called CoWoS.
Okay, let's unpack this. What exactly is CoWoS and why is it causing such a massive bottleneck?
Yeah, so think of traditional computer chips like a sprawling suburb. You have different components spread out on a motherboard, and data has to commute back and forth between them.
And that commute takes time.
Right, it takes time and it burns energy.
Yeah.
So CoWoS, which stands for chip on wafer on substrate, is like building a massive, ultra-dense skyscraper instead of a suburb. You are physically stacking the processors and the memory on top of each other and wiring them together at a microscopic level.
So the data doesn't have to commute anymore.
Exactly, just takes the elevator. This is literally the only way to get the blistering speed required for AI accelerators from companies like NVIDIA. But building these microscopic skyscrapers requires incredibly specialized, painstaking manufacturing.
And demand for those chips is just outstripping the physical capacity to put them together.
By a wide margin, yeah.
So if we think about AI as this massive, blazing industrial furnace, these highly specialized memory chips and the electrical grids powering them are basically the coal. And the demand for that coal is breaking the supply chain. TrendForce is reporting that the price of DRAM, which is the short-term working memory of a computer, surged nearly 100% in just the first quarter of 2026.
And we're expecting another 50% rise in Q2, which forces everyone's hand downstream, right? Apple managed to hit a record 20% global smartphone share in Q2 recently, but primarily because they absorbed those memory costs.
They kept iPhone prices flat while their rivals had to raise theirs.
Exactly. But they can't hold out forever. They've already raised Mac and iPad prices by up to $500 to compensate. And the sources indicate a price hike for the iPhone 18 is fully expected this fall.
Wait, I need to push back on this. Isn't technology supposed to be deflationary? For decades, the fundamental rule of tech was that it scales endlessly. It makes everything, from TVs to computers to data storage, cheaper and more accessible over time. Why is this suddenly making everything more expensive?
What's fascinating here is that the sheer scale of the physical infrastructure required to build this generation of AI has temporarily inverted that rule. You have economists at major banks like JP Morgan and Goldman Sachs explicitly warning that the AI build-out is actively inflationary right now.
Meaning it's actually driving up the cost of living for everyday people.
Precisely. The race to build the smartest models requires so much raw material, so much specialized silicon, and just so much baseline power that it is driving up the cost of everyday consumer electronics.
And utility bills, right?
Oh, absolutely. Goldman Sachs is forecasting electricity prices to rise 6% this year, another 6% in 2027, and 3% in 2028, specifically because AI data centers are absorbing all the new electrical capacity on the grid.
Wow.
Yeah, the infrastructure is so incredibly expensive to build that the costs are bleeding directly into your monthly utility bills.
So if AI is consuming so many physical resources that it's driving global inflation, what happens if the return on that investment takes, I don't know, 10 years to materialize? Or what if the bubble just pops?
That is the million-dollar question.
Because we're seeing tech stocks falling today because investors are fiercely debating these AI return on investment timelines. And this structural anxiety over how long it will take AI to actually pay for itself is being compounded by renewed U.S.-Iran hostilities in the Middle East, which, as a quick aside, is a very sharp reversal from that tentative peace agreement on the Strait of Hormuz we saw reported just back on May 31st.
Yeah, and obviously the geopolitical volatility in the Middle East is certainly rattling supply chains.
Yeah.
But the deeper, more structural anxiety for these tech stocks is the sheer size of the AI capital expenditure.
The spending's just massive.
Right. Investors are looking at the billions being spent on data centers and realizing that the deployment phase of AI is going to be incredibly long and incredibly expensive.
And we are seeing warnings that this isn't just a localized tech problem anymore. Career analysts at the U.S. Treasury are warning that this AI infrastructure boom is now, and this is a quote, too entrenched to unwind quietly.
That's a terrifying phrase.
Right. If there's a sudden downturn in AI investment, it wouldn't just be a tech stock correction. They're projecting it would crash private credit markets and even the utility companies that have dedicated all their future capacity to these data centers. And over in the UK, regulators have just placed AWS, Google Cloud, Microsoft Azure, and Oracle under financial systemic risk supervision.
Which is a massive shift in regulatory posture. I mean, that is the first time any major economy has imposed this kind of oversight on cloud computing.
So does this UK regulation essentially mean we have to treat cloud providers like massive banks now? Are they literally too big to fail?
If we connect this to the bigger picture, the answer is essentially yes. These tech giants, the hyperscalers as they're called, because they operate data centers at a massive global scale, they become the load-bearing walls of global finance.
Wow.
Systemic risk supervision means regulators are going to stress test them the exact same way they stress test a major bank. Because if a major cloud provider goes down today or faces a severe credit crisis, it doesn't just mean your email is offline.
Right.
It means global payment networks, stock exchanges, and private credit pipelines just freeze. The underlying plumbing of our economy is now inextricably linked to the success of these AI data centers. And investors aren't asking if AI will pay off anymore, they're asking when.
So the physical infrastructure is foundational, it's expensive, and potentially a massive systemic risk. Let's look at how companies are actually using this power at the software layer to justify the expense. Because we have an extreme productivity case from a tech company called Bending Spoons. In 2025, they had 800,000 job applications.
That's a lot of resumes.
Yeah, and they only hired 286 people.
Because by the first quarter of 2026, they had AI automating 90% of their code pull requests.
Now, for those of you not living in software development all day, a pull request is essentially a developer submitting a draft of new code and asking the team to review and approve it before it goes live.
Right. It used to require human engineers carefully reading line after line of code to spot bugs or conflicts. But Bending Spoons handed almost all of that over to autonomous AI agents.
Which is wild.
It really is. That intense automation allowed a tiny workforce to manage a massive code base, pushing their revenue per employee to an astonishing $2.57 million. It is a concrete benchmark for what we call workforce compression.
Here's where it gets really interesting, though. AI allows 286 people to do the work of thousands, but at the exact same time, it creates these terrifying, centralized, single points of failure.
Yes.
The sources detail a compromised release of a public code package called JScrambler, specifically version 8.14 and .0. It dropped what's called a Rust-based info stealer. And this malware specifically targets the configuration files for all the major AI coding assistants, things like Claude Desktop, Cursor, Windsurf, VS Code, and Zed.
This is a classic supply chain attack, but it's hyper-targeted. Developers use public libraries like JScrambler to save time so they don't have to reinvent the wheel for every single line of code.
Makes sense.
Right. But if a hacker manages to slip malicious code into a popular public library, it's like poisoning a city's water supply. Anyone who downloads that library gets infected.
Yeah.
But this info stealer wasn't looking for credit cards. It was specifically hunting for the access tokens used by these AI coding assistants.
And to make matters worse, a Hacker News analysis just found that an AI development tool called the Grok Build CLI has been uploading entire corporate code repositories to a SpaceX AI Google Cloud bucket. And it's literally named Grok Code Session Traces.
Yeah, that's not great.
No, not just the specific files it needs to read to do its job, but the entire architecture of a company's software.
This raises an important question about the fundamental trust we are placing in these systems, especially for enterprise and government clients. AI models need massive amounts of context to be useful. To help you write a single function, the AI really needs to understand how your entire application is structured.
So it just scoops everything up.
Exactly. Tools are increasingly scooping up whole code bases and sending them to the cloud for processing. But when you do that, you are taking your company's most valuable intellectual property and piping it directly into a third-party server.
So let me get this straight. You compress your workforce down to 286 people because the AI is so incredibly efficient. But because those 286 people are relying so heavily on autonomous AI tools, one overly aggressive Grok data upload or one poison public code library could instantly expose the core logic of your entire business to hackers or competitors.
Yeah, that is the double-edged sword of workforce compression. You reduce your headcount, but you concentrate your security surface area into these incredibly dense, high-value targets.
Well, as powerful as AI is in that digital realm, the sources today make it incredibly clear that it is rapidly escaping the screen and moving into the physical world. We're taking the logic models that were analyzing text and giving them physical bodies.
We are seeing a massive shift toward edge computing. Instead of sending data back to a massive server farm to be processed, we are compressing these AI models so they can run locally, on a device, in real time.
And a prime example of this is a new EU mandate that just went into effect on July 7th. It requires AI-powered gaze monitoring driver distraction systems in all newly registered cars.
Which is huge.
Yeah, the car is literally running real-time AI inference, analyzing your head movement and eye gaze to make sure you are watching the road without actually transmitting the video footage anywhere.
It is arguably the most sweeping AI safety requirement ever imposed on a legacy industry. Every new car sold in Europe is now essentially an edge computing device.
And it doesn't stop at cars. Hyundai's board just approved a restructuring for Boston Dynamics ahead of a July 20th SoftBank put option deadline. This is to fund the commercial deployment of their Atlas humanoids. And at the exact same time, a robotics company called Unitree is pushing out their R1 humanoid robot, targeting 10,000 to 20,000 units in 2026 at a sub-$100,000 price point for industrial use.
So physical AI is rapidly shifting from expensive research labs to light industrial factory floors. They are building robots cheap enough that a warehouse manager can actually justify the return on investment.
But all of this physical movement, I mean, the cars, the robots, the coding agents, it brings us right back to the original bottleneck. Power. The terrestrial power grid simply cannot support this growth, which leads to a wild story in the IPO filings for SpaceX. In 2025 alone, SpaceX spent $12.7 billion on AI.
Which is staggering.
It's 3 times what they spend on their actual space launch business. Why? Because they are actively planning to launch orbital AI data centers by 2028.
They literally want to put the compute in space.
Yes. You know, back on June 2nd, there was a news story about federal authorities finding a 2,000-foot drug tunnel connecting Mexico to the U.S.
Okay, where are you going with this?
It's a bizarre analogy, I know, but hear me out. When humans face an immovable physical barrier, they will literally dig a 2,000-foot tunnel through the dirt just to bypass it. SpaceX is looking at the terrestrial power grid and the zoning laws on Earth as an immovable barrier, so they are bypassing it entirely by shooting the data centers into orbit.
You know, the mechanics of that bypass are actually incredibly sound.
Really?
Yeah, because on Earth, you have to fight for permits, you have to find massive amounts of fresh water to cool the servers, and you are constrained by a fragile power grid. In orbit, you have uninterrupted, unfiltered solar power. You have the natural freezing vacuum of space to handle the cooling. A company with launch capabilities looks at the ultimate unrestricted physical frontier and sees a permanent solution to the AI compute bottleneck.
Which brings us to the ultimate climax of all this movement. We have AI embedded in our cars, making our financial systems too big to fail, and soon orbiting over our heads. So who actually controls the rules And who is building the smartest brain?
That is the race we're in right now.
The global governance race is hitting a fever pitch this week. The Washington Post has a massive piece detailing an unresolved legal debate over AI chatbot liability. When an autonomous agent does something wrong, say it gives dangerous medical advice or hallucinates a defamatory claim, who is legally responsible? The developer who trained it, the company deploying it, the user who prompted it.
The friction is happening because traditional definitions of product liability just don't map neatly onto autonomous generative systems. The technology is completely outpacing the legal frameworks.
We already saw this tension flare up back on June 1st when Florida became the first state to sue OpenAI over ChatGPT safety failures, which, just to be clear, we are simply reporting on the legal friction here, not taking sides on the lawsuit itself, but we are seeing companies putting up their own defensive walls regardless. Cloudflare is launching a granular AI bot management tool. Starting September 15th, it will default to blocking AI agent and training crawlers on ad-supported websites.
The open web is actively trying to lock its doors.
And geopolitically, the stakes are peaking right now. Chinese President Xi Jinping is delivering the first ever presidential keynote at the World AI Conference in Shanghai on July 17th, heavily signaling a push to lead global AI governance. Again, just looking at the facts of the international rivalry here. So what does this all mean for the immediate future?
It means we are on a collision course, and mid-July is the epicenter. Consider the convergence of events here. On the exact same day that Xi Jinping addresses the World AI Conference, July 17th, Google is launching Gemini 3.5 Pro for general availability. This model features a 2 million token context window.
Let's explain what that actually means, because tokens can sound a bit abstract.
Right, so a token is basically a piece of a word. The context window is how much information the AI can hold in its working memory at one exact moment. A 2 million token window means the AI isn't just answering a quick question.
It's massive.
Yeah, it can read the equivalent of the entire Lord of the Rings trilogy, plus all the appendices, memorize every single character interaction, and then answer a complex question about the overarching themes of the text in seconds. And Google has priced this capability at a highly disruptive $1.25 per million input tokens.
Wow.
They have made it so cheap to process information that analyzing entire textbooks of data now costs literal pennies.
And while Google drops the price, Elon Musk is claiming his Grok 4.5 model is accelerating fastest, hitting 80 tokens per second with an imminent EU launch. And just the day before all of this, on Thursday, July 16th, TSMC will release its full Q2 earnings, which will signal to the market their full year's AI guidance and CapEx plans.
We are watching the cost of intelligence plummet,
Yeah.
the speed of inference skyrocket, and global superpowers scrambling to establish dominance over how it is governed, all simultaneously.
It is an absolute frantic sprint. We are completely consumed by speed, acceleration, and scaling this new intelligence as fast as physically possible. But looking at all this frenzy on Earth, there is one final detail in the sources that offers a really profound contrast. NASA just announced that the New Horizons probe has awakened from hibernation.
That's incredible.
It really is. It is currently operating approximately 6 billion miles from Earth, out past Pluto, and the science team is reactivating its instruments for the Kuiper Belt.
The engineering required to maintain functionality that far out in the solar system for that many years is just remarkable.
Right. Because New Horizons was built decades ago. It runs on traditional, purely human-coded technology. It is slow, it is methodical, and yet it functions flawlessly in the harshest environment imaginable 6 billion miles away after years of absolute silence. So as you go about your day and you think about how we are rushing to hand everything over to these rapidly iterating, incredibly complex AI systems, our financial markets, our corporate code bases, even the safety systems in our cars, ask yourself something. Will these new AI-driven systems possess that same multi-decade fail-safe endurance? Or are we trading long-term human-coded resilience for short-term automated acceleration?
That really is the defining engineering question of our era.
Thank you so much for joining us on today's deep dive. Keep questioning the systems around you, and we will see you next time.